Right, so today we are going to talk about sums of arithmetic progressions. In a previous video, we talked about sum of numbers from 1 to 100, and we saw a nice trick of how to do it. And today we are going to talk in a slightly more detail about what these sums of arithmetic progressions are and how we can do them in general. And we are going to start with a slightly more complex example than what we did earlier. And before we begin, so what is an arithmetic progression? I use this word a couple of times. So what is it? Arithmetic progression is, think of it as a series of the form x plus y, x plus 2y, x plus 3y, and so on, where x is the starting term and the common difference is y. The difference between successive terms is constant, or y. So for example, 5, 7, 9, 11 is an arithmetic progression because the common difference is constant. But for example, 5, 7, 10, 15, 20, this is not an arithmetic progression because the common difference is not the same between the terms. So let's talk about this specific problem, and then we will talk about in general how we are supposed to solve this. So the question is, calculate the sum of all numbers divisible by 5 between 100 and 1000, both inclusive. Both inclusive just means that the numbers, when we say between does not always mean inclusive. It could be exclusive. That means excluding the numbers 1 and 1000, or rather 100 and 1000. So here it is being made explicit that both the limits, that is 100 and 1000, are included in the series. So in other words, what we want is this summation s is equal to, let's say, 100 plus 105 plus 110 plus all the way plus 995 plus 1000. This is the sum we want. And in general, this is only a slightly tedious problem. We can do this summation by hand, but again, as mentioned before, there has to be a better way of doing it. So the way we did it last time was to write the summation s again in reverse. We are going to try to do the same thing and see where it leads us. So s is also equal to, I'm going to write it in the reverse, which is 1000 plus 995 plus 990 plus so on all the way to plus 105 plus 100. So this is my summation, and I can add this to get left hand side is 2s is equal to the sum of 100 and 1000 is 1100 plus the sum of these two terms is again 1100 plus all the way, all the terms are 1100. So 2s is equal to this 1100 times the number of terms here. Let's call this number of terms is n. What is our n? If we can find n, then we can do this summation, because we know this 2s is equal to 1100 times n, where n is the number of terms. And finding n should not be difficult, because each 100 has 20 numbers divisible by 5. So there are, from, let's say, from 100 to 200, 200 to 300, 300 to 400, there are 9 such hundreds between 100 and 1000. We have to be a little careful about the limits, but approximately, as a first approximation, there is going to be 20 terms in each of them. So that's 20 terms, and there are 9 such centuries or 9 such hundreds. So that is going to be 180 terms, plus we have the last number 1000, which is not in any of these hundreds, but it's an additional number that is divisible by 5. So n is equal to 181. Let's see if it is possible to also derive it using another method. So this 100 and 1000, right? So I need to find out how many gaps of 5 exist between them, which is going to be 1000 minus 100 divided by 5, which is 900 divided by 5, which is 180. So there are 180 gaps of 5. There are think of it as 180 bricks I can lay. So this is a number line. Let's say this is 1000, and this is 100, and I'm going to mark these gaps of 5 each. So think of these as gaps or bricks. Each is a brick of size 5. So I can lay 180 bricks like this. But so each brick has 2 endpoints, and each endpoint is divisible by 5. So the total number of numbers I have is again as before 180 plus 1, which is 181. So n is equal to 181, and therefore our answer is simple now. So s is half times 1100 times 181. As a sanity check, so 2 divides 1100, this is 550. So we are getting an answer that is an integer. So s is basically whatever this, I'm not going to do this multiplication, but s is 550 times 181. This is much simpler, and it can be done with a calculator rather quickly rather than actually adding these 1000 numbers or 181 numbers. And in general, this actually leads us to an interesting question and a simple answer to the question. It's, so suppose I'm given a general arithmetic progression, which is a plus d, a plus 2d, a plus n minus 1 times d. This is a standard notation. A is the first term, d is the common difference, and n is the number of terms. So the last term is a plus n minus 1 times d. So what is the sum of this arithmetic progression? Again, let's try as before. A plus d plus a plus 2d plus all the way a plus n minus 1 times d. Let's write it in reverse. S is also equal to a plus n minus 1 times d plus so on all the way plus a. So 2s, adding these two, is equal to a plus n d. What am I saying? Sorry. 2a plus n minus 1 times d. I confused visually between this a and d. So the sum of these terms is 2a plus n minus 1 times d times the number of terms is n. So summation is equal to n by 2 times 2a plus n minus 1 times d. So another way of looking at it is I can also write this as n times half times 2a plus n minus 1 times d, which is basically saying this half of 2a plus n minus 1d is the average value of the first and last, or the second and the second last terms, and so on. And there are n total terms like this. If I'm taking average, I have to multiply by the total number of terms to get the total sum. So s is equal to n by 2 times 2a plus n minus 1 times d. That is the general formula we get, which can also be interpreted as the average times the number of terms. Okay, so this is how we can solve for the sum of a general arithmetic progression. Maybe in a later video we will talk about a geometric progression, where the numbers in the progression are not in an arithmetic progression, but they are in a geometric progression. That means the ratio is constant. So numbers like 1, 2, 4, 8, 16, 32 and so on, where the numbers are multiples, so the next number is a previous number times a constant. But maybe that is for a later video. All right, thank you.